This is the very, very important concept. Creation of Coriolis force. Creation of Coriolis force, which is a deflective force. Just imagine you are traveling on a bike. Okay, it is in the motion. All of a sudden you are jumping out of the bike while it is moving. Okay, after jumping from the bike, can you stand there? You will be dragged in the direction of the bike. If velocity is greater, you will be dragged to a greater extent. Okay, if it is lesser, okay, damage would be minimal. Why? What's the reason for that? Is it friction? This damage is due to the friction between your body and the road. Okay, but why you are being dragged? I'm asking that. Because as it is in the motion, that brings some kind of, exerts some kind of deflection on your part. You will be deflected in the direction of the bike. It is because of the velocity. We all know that earth rotates from west to east. Okay, so bike is moving from west to east. In the direction of the bike, there works or there created a kind of deflective force called Coriolis force. Okay, now under this you have two important points. First of all, if you take northern hemisphere and southern hemisphere, this is north pole and this is south pole. Okay, now I am starting my journey from the equator towards north pole. Okay, I am trying to move towards the north pole. If I am facing the north pole, to which side I should get deflected in this case? I am facing the north pole. This is the equator, that is the north pole. I'm starting towards the north pole like this. Okay, so in this phase, completely in this journey, to which side I should get deflected? If bike is moving like this, why should I get deflected? For example, you are jumping out of the bike like this. It is moving like this. You will be dragged in the direction of the bike. Am I clear? Okay, which means that what about the Coriolis force which is working here? It is from west to east. Bike is moving from here to here. Then how can you expect me to drag in this direction or in this direction? I should be dragged in this direction, right? You got the point. Okay, so as earth is rotating like this, which means that deflective force is working from west to east, towards the east. When I start moving towards north pole, I should be dragged in this direction. Got the point? Okay, so which means that I should get deflected to the right, to my right, because I am facing the north pole, in the sense this becomes my right and this becomes my left. Got the point? So can I say that due to the impact of Coriolis force, winds are deflected to the right in northern hemisphere? In my place, instead of me, just assume wind is moving. Okay, and that wind should get deflected to the right or left? Right. Why? Because rotation is from west to east, right? Okay, from here to here you have the rotation, west to east. Okay, in the second case, I am changing my facing. Okay, I am facing the south pole. From here I am moving towards the south pole. Now during this journey, I should get deflected to the right or left? If I am facing the south pole like this, this becomes my right and this becomes my left. So I should get deflected to my left. Why? Because the direction is like this. Side is always same, but due to the change in facing, it is becoming right in northern hemisphere, it is becoming left in southern hemisphere. So because of the Coriolis force, winds are deflected to the left in southern hemisphere. This is right and this is left. Okay, observe here. So regular path should be like this, but rotation of the earth's direction is from west to east. Okay, so bike is moving like this, so you should get deflected to the right. So that is why it is right side deflection. Now in the second case, I am changing the facing. I am facing the south pole, so my right becomes left, left becomes right in the southern hemisphere. So I should get deflected to my left, but side is always same. Side is always same. That is nothing but towards east. Am I clear? So this is the first point. Second point, we all know that Earth is geared in its structure. So based on that, can I say that equator is the longest diameter of the Earth? Equator is the longest diameter of the Earth, no doubt about it. Okay. What is the difference between diameter and radius? Okay. A diameter is comprised of two radiuses. Okay. Here you have diameter 1, which is comprised of R1 and R2. And here you have one more diameter, that is D2, which is comprised of R3 and R4. Okay. Now, R1 and R3, in between the both, which one should be longer? R1. R2 and R4, obviously it must be R2. Okay, right. So from the equator towards the poles, the length of radius is decreasing. You have a formula called L. L is nothing but angular momentum. Angular momentum is the product of mass of the object, velocity of the object, and radius of the object, mvr. This is the principle. Angular momentum is equal to mvr, mass, velocity, and radius. Now take the relationship between the both, velocity and radius. Both are inversely proportional. Okay, if radius is less, velocity should be more, and vice versa. Now based on this, where can you expect greater velocity, at the equator or at the pole? At the pole. Got the point? Okay. So one person is traveling on a bike at the equator at a lesser velocity, and other person is traveling on a bike in the polar region at a greater velocity. Now where can you expect the more deflection? Where can you expect you being dragged to a greater extent? At the equator or at the pole? Pole. Okay, based on this, can I say that the intensity of Coriolis force increases from the equator towards the poles? So winds are deflected to a greater extent in the polar regions. Do you agree with that? Okay. This is to with your Coriolis force.